Hi, my name is Eric Jamois. Thank you for joining me in this ADMET Predictor interactive tutorial dedicated to MedChem Designer. So the topics for today are to work with MedChem Designer, to edit structures, and also to create and save new structures. We will also see how to calculate ADMET properties within MedChem Designer. So without further ado, I'm going to open a file that we have worked with before, which is this set of 500 pyridoxazepinones. So we're going to open this file, which we used in the previous tutorial. And as you remember, the identifiers for the compounds were captured in an identifier field labeled as EDX. So we're going to specify this as the proper field for our identifiers. And so we've loaded our set of 500 compounds here. There's several ways that you can actually invoke MedChem Designer from ADMET Predictor. The first way is to look on the icons here, and you will see an aldehyde in this top bar. And if you hover over it, it'll say MedChem Designer. If you click on this, it will actually open a MedChem Designer window. So that's the first way. The second way is to double click on one of the structures contained in the table. Okay. And for example, if we double click on this first structure here, it appears, and then we can drag it in the middle if we want to have a little bit more real estate, and say we've identified an issue where this compound, say, was drawn wrong, that this oxygen here should really be a nitrogen. So for example, we may want to edit this compound. And so in order to do this, we would select the nitrogen icon and just select here, okay? Now to correct the structure, what you would do is press this transfer arrow key, this left pointing arrow, to put the structure back in the spreadsheet under its new form. And so a dialog will open to let you know that you will be transferring a compound from MedChem Designer. And this is actually an existing compound in the spreadsheet, which is going to be modified by this operation. Okay. And the software actually does keep track of the previous incarnation of this molecule. And also, of course, is providing the new and updated structure for it. Okay. The other way to go about it would be to, for example, create a new structure from one of the compounds in this table. So if you take, say, for example, compound 3, double click on it in the same way we did previously, and likewise, we're going to bring it in the center of our screen here so we see a little bit better. For example, we may want to modify this fluorine into a trifluoromethyl group. And the way you would do this is select the carbon atom here and then change this fluorine into a carbon. It's very simple. Then you would select the bond tool and draw 3 bonds to this carbon and then label them with fluorine atoms. 1, 2, 3. Okay. At this point, one of the things you may want to do is to clean up this molecule. So for example, by selecting it, if you right mouse click it, you can clean it up, meaning give it a depiction that you like. And there are multiple options. You can also flip this molecule now horizontally or vertically to reach the orientation that you want to see it. You can also rotate it with this 2D rotate tool. You can select one of the atoms on the molecule and then rotate it, okay, until again you reach a depiction that you like. Okay. What we haven't done yet, because we have a new molecule here, is we haven't named it. So we can actually name it by just modifying its name. And we can just take the parent name and then give it an underscore CF3. So underscore CF3. And we say OK. And now if we click this transfer arrow, it will add this molecule, because this is a new molecule, it will add it to our table. So it's letting us know prior to this operation that we'll be transferring the molecule, and it's actually a new compound that will be appended to the spreadsheet. So we click OK to operate this transfer. Now, if we go to the bottom of our table, instead of having 500 compounds, we actually have 501. And as you will see, this molecule is under the orientation that we gave it when we cleaned it up and oriented it. Okay, so the other things that you can do, let's go back to our MedChem Designer window here. The other thing that we can do is save the structure. So we can save it under the ADMET Predictor .csk format. If we go, all right, and we can also export it as an SDF, which is a more common format. So under export, now we're going to give it the same name. And there we go. Okay. The other thing that we can do is actually export it similarly as a depiction. So we can export it as a JPEG. For example, if you wanted to add this into a Word document or in a PowerPoint presentation, and you needed a depiction of the molecule, you could use this file type in order to do that. Just go ahead and hit save, and now we have different files. We have an SDF, we have the CSK, the JPEG, and then the SDF. So we've saved it under 3 different formats. If we double click on the JPEG, then now we have the graphical depiction of the compound. Okay, just a very simple process here. So what we can do is now open a new session, a new window for MedChem Designer. And instead of taking just one structure to MedChem Designer, we'll actually take a whole set of structures. Actually, you can send up to 100 structures or import as many as 100 structures in MedChem Designer. And in order to take them there, what we need to do is hit this MedChem Designer button here in our icons at the top. Okay. And one of the cool things we can do, as you notice here, those compounds are somewhat randomly oriented because that's probably the way they were drawn by the chemist who entered them. So there was no privileged orientation for these molecules. And what we can do is actually align them, for example, by common scaffold. That's a very useful tool. And now we're looking at these molecules in the same orientation. And we can send them back to the ADMET Predictor table, okay, this way. And they will all appear now in the same orientation. So again, you can do that for up to 100 structures at a time. You can even do it on a much larger number of structures using MedChem Studio, but this is not within the scope of MedChem Designer. So we're going to keep going. The other thing that I wanted to say here is that we really haven't lost anything in going across several windows. All the information that we had before is all in these separate windows and available to us. So we really haven't lost anything along the way. That information is still there. So let's go back to our set of 10 structures here, one of the cool things we can do is actually calculate ADMET properties within the MedChem Designer environment. So notice here you have this ADMET Properties icon, and if you select this, the software will actually calculate ADMET properties for these molecules. So I have all the licenses activated here, so actually the entire panel of ADMET properties has been calculated. These are in individual rows, and in your columns you have the 10 compounds that we had brought from ADMET Predictor. So this is kind of a neat way that you could inspect what the changes in predicted endpoints are as a function of the chemical changes that are maybe some subtle chemical changes that are made across this set of molecules at the top. Okay. Now, at this point, we can actually export these molecules as an SDF file. And so let's export them as PO_export 10. So we're going to export these 10 molecules to an SDF file. And notice that the software is asking us if we want to export the ADMET attributes, which are all the endpoints we calculated, alongside with the structures. And yes, that's an interesting thing to do. So we're going to go ahead and do this. Okay. Now, if we go back to our ADMET Predictor window and go and open this file, export 10.sdf, then we will be bringing these compounds in alongside with the properties. And actually, there was an option in the box that you can either just read in the structures or you can read in the structures with all the properties that are associated to them. Notice something here, that there are values for the endpoints which are in red. This is a convention within MedChem Designer and also ADMET Predictor to flag out of scope predictions. So here we have an out of scope prediction for this model for this particular compound. Note that it is not the same situation for the other compounds across the series, which are actually fine. There may be a couple. Yeah, there's one more. So anyway, this is those are very important flags as far as the predictions are concerned. Note that this convention is carried forward when you bring in the compounds into ADMET Predictor. Again, we have the similar convention that those compounds that are out of scope for the endpoints will be underlined red. Let's now open yet another new MedChem Designer window. And what we're going to do here is deal with a completely different situation. Say we're interested in bringing in structures from resources that are on the web. So we've seen some compounds that relate to our compounds or compounds that we would like to bring in. So for example, we've seen resveratrol. We would like to bring in this compound. So this is actually Drug Bank, and which is a very useful resource. And if we scroll down here, we see a depiction of resveratrol. There's also a download, several download options actually. So if we want to see what's under that, you actually have the option to export this molecule as an SDF file. So if you right mouse click, let's go and save it here, and we're going to give it its real name, which is resveratrol. Okay, and just say save, and it saved it. Now we can go to MedChem Designer and say open, and resveratrol is here. Okay. So that's one way to bring it in. There's even an easier way. So let's go back to our web resource here. And you see that there's actually, it has the ability to give us the smile string for this compound. So if we select smiles, the smile strings appears here. And the only thing you need to do is copy it. So Control C, we're copying our smiles. And then Control V into our MedChem Designer window, and the compound appears. Okay. So we're going to name this compound. We're going to call it resveratrol. And we can copy and paste it. Say we want to make a few analogs of this compound to study, say, the effects of different R groups on the predicted properties. We just say Control C and then Control V twice if we want to make 2 copies of it. It's a very simple thing to do. Say, for example, that we want to reduce this to the scaffold. All we need to do is select the eraser and erase those hydroxyl groups. And now we just have the scaffold. So we're going to name it differently. Res_scaffold. Okay. And say, for example, that we're interested in other analogs of resveratrol, and there are actually some. If you look here for similar structures, there is a compound called picetanol, which may be interesting to include as, again, one of the analogs. So this compound's very easy to get to. Here, simply select your atom connection tool, click on this position, and then put a hydroxy group. Okay, and now we're going to give it its name. So we're going to select it. Same process as we've done before, right mouse click, modify the name, and picetanol. All right. Now we can go through the same process as we've done before, which is to, for example, calculate ADMET properties for these 3 compounds. Okay. So again, we can go down the list. It's a very easy way to inspect the different properties. Let's bring yet another MedChem Designer window. If you are familiar with the smiles language and you want to enter your own smile strings, you could also proceed that way. So what we're doing here, we're really going through the different ways that you can get your own structures into the software. We've already seen a few ways to either modify existing structures or to bring them in through files. Again, you can also bring them in by entering specific smile strings. So under Edit, say Paste Smiles, and here you can put in your own smile strings. Say, for example, you would like to bring in propionic acid, then the smile string for that would be CCC, then double bond O and O. Okay, and then you can give it its name here, propionic acid. Okay, what it will do before you bring the structure in, you can actually display it to make sure it's correct. And if you see that it's not, then you have an opportunity to modify the smiles. Okay, so this is now your compound. Now, of course, in some cases, you may be forced to sketch a structure from scratch. So that's actually what we're going to do now. So we're going to take yet a new window, and we're actually going to sketch a brand new structure from scratch. So let's look for a structure. Maybe we could sketch fentanyl, for example. And here it comes. And if we want to see it larger, we can simply click on it, which is going to make it quite a bit easier to draw, okay, if it's larger. So let's go ahead and draw this molecule. So we would start by building the carbon backbone. Maybe put it in full here. So first carbon, second carbon, third carbon. Now we're going to bring a cyclohexyl ring. We'll worry about the heteroatoms later. We go back to our bond tool. Again, sketch the carbon backbone. Now we're going to sketch our carbonyl. And the way you get a double bond is simply click in the middle of the single bond. It'll turn it into a double bond. Okay. All right. Now we're going to bring in our phenyl rings. Before we do that, I'd like to show you a pretty neat tool that if you've got some macrocycles, you can actually bring in macrocycles of various sizes. So this number here describes the size of the ring. So if you want a 10-member macrocycle, then you can simply click on this icon, and if you wanted to fuse it to this ring, simply click here and it will fuse it. Of course, we don't want to do that, but it's kind of a neat tool, and I thought I would show you because sometimes drawing these large macrocycles freehand is pretty challenging, so it's definitely a very useful tool. Now let's put in our benzene rings. So we'll put one here and one here. Now let's put in our nitrogen atoms, one here and one here, and our carbonyl. And that's it. So we're done with our structure. It's very simple to do. And at this point, we probably want to give it its name. So again, right mouse click, modify name. This is fentanyl. And if we want to save it, now we no longer need this resource. And if we want to save it, just say save as, and we can save it under our CSK format as fentanyl. And save. So that's, again, it's a very easy process. Even if you don't have a way to bring in the file, it's still reasonably straightforward to sketch in your own structures. If you want to look into more detail into aspects of ADMET Predictor or MedChem Designer, I'm reminding you that you have a very easy access to our extensive manual under ADMET Predictor Help, either in PDF or HTML format, and you're free to look into any of the details associated with what I just presented. So again, I hope that was useful. Thank you very much for your attention, and you have a wonderful rest of the day. All right, bye now.